Right, consider this physics question. A guitar string is 75 centimeters long. The wavelength of its fundamental note is dash. So we have the options. This is JAMB 1978, question 33. So this is a question on sound wave, particularly sound instruments. So this has to do with vibration in strings, or in a string. So for example, one of the sound instruments that can be used to solve this question is a guitar. So let's say we have the two fixed points, the two fixed ends in a guitar. So in every guitar we have a string. Let me denote the string like this. So the simplest vibration that you can have in this guitar is when you have a single loop like this. Like if you pluck the guitar. So this is the simplest vibration that you can have, the one that will go up and down like this. So it will create a circular loop like this. So if you know about stationary wave very well, you will understand that this is a part of a stationary wave. So this end serve as the node. This is another node, the two ends, while the middle serve as the antinode. And the distance between two nodes or two antinodes in a stationary wave is denoted as half wavelength. So, but the difference between three successive nodes, but this is two successive nodes, that is half wavelength. That's lambda over 2. So that means the length of this string is equal to lambda over 2. So by the time I make lambda the subject of formula, I have lambda equal to 2 times L. 2 times L. So this is the wavelength of the fundamental frequency. So this loop that we have here is the fundamental loop. So this is the fundamental vibration. You can also call it the first harmonic. The first harmonic. So this is the vibration of the first harmonic. So the one that forms only a single loop or one segment like this is known as fundamental note. So now, to get the lambda, I will just substitute for L. You know that the length of this string from the question is 75 centimeters. So I'll put 75 here. That means lambda equal to 2 times 75 centimeters. That will give me 150 centimeters. That is the wavelength of the fundamental node. Check the options. See the option B is the correct answer. Thank you. God bless you.